This video is on the composition of functions. Earlier we talked about functions being combined by arithmetic operations, but this is a little bit different, the composition of functions. The composition of two functions, f and g, can be defined by f of g of x. Notice the little circle symbol, f of g of x. In this case, we're actually taking g of x and we're taking it and putting it inside of the function f. So f of g, you're picking it up and putting it into the f function. For all x in the domain of g such that g of x is in the domain of f. Now we could reverse this process. If I wanted to find g of f of x, we would actually pick up f and put it in for g, and then work out the algebra to simplify the expression. In this problem, it says find f of g of x, given that f of x is 2x minus 7, and g of x is negative x plus 5. So in this case, what I'm going to do, since g of x is inside, we're going to actually pick it up and replace it in the variable, substitute it in for the variables of f. So this would actually equal 2 times, instead of x, we're going to put in negative x plus 5 minus 7. And then work out the expression. So that would be negative 2x plus 10 minus 7. You can combine 10 minus 7, so you have negative 2x plus 3. Now, since g of x is what we're putting in, there's no restriction on either domain here, so my domain would still stay all real numbers. But this is the composition, f of g of x, negative 2x plus 3. And this one was find g of f of x. So since f of x is listed separately or secondly in the expression, we're going to pick up f and we're going to put it into g. So we're going to do the 2x minus 7. We're going to substitute it into the variables of g. So in this one, g of f of x, we would have negative 2x minus 7 plus 5. So we distribute the negative, negative 2x plus 7 plus 5. So you get negative 2x plus 12. Find g of f of x. F of x is 3x minus 4. G is x squared plus 3x minus 4. So we're going to actually pick up f this time and put it into the variables of g. So that's going to be 3x minus 4 squared plus 3 times 3x minus 4 minus 4. So a little bit harder algebra to clean up this time. I've got to square the binomial, so we could write that down twice and do the FOIL method, or you can use the expansion process. 3x, if I square that, I get 9x squared. Multiply the two terms together and double it. 3x times negative 4 would make negative 12x. Double that would be negative 24x. And then square the last term. Square the negative 4, I get plus 16. Then distribute your 3, so 9x, and then minus 12, and minus 4. So now combining like terms, I will get 9x squared. Negative 24x plus 9x is negative 15x. And then 16 minus 12, that's 4. 4 minus 4 is 0. So this is actually the combined simplified version for g of f of x. Since neither domain was restricted, the domain would be all real numbers also for this example. In this last example, you'll notice it's not just the instructions tell us to find f of g of negative 1. Not to find f of g of x, but f of g of negative 1. So one approach we could take with a problem like this is to find f of g of x and then substitute negative 1 in for the function and find out the value. So let's do it that way. Let's first find f of g of x. So we're going to pick g up and replace it in for the variables of f. So that would be 2 times negative 6x minus 1 squared plus 3. Simplifying that out, we get 2 times. We need to square the binomial, so that will be 36x squared. If you multiply that, you get 6x, double that, so it would be plus 12x plus 1, and then plus 3. Multiply through by 2 is 72x squared plus 24x plus 2 plus 3. So that's 72x squared plus 24x plus 5. So the last step would be find f of g of negative 1. So if I plug negative 1 in, that's 72 times negative 1 squared plus 24 times negative 1 plus 5. So that would be 72. Negative 1 squared is just 1. So minus 24 plus 5, which would equal 53. Now, another way that you could have approached this is by doing this. Find g of negative 1 first. G of negative 1. So if I plug negative 1 into this, that would give me 6 minus 1, which would be 5. So g of negative 1 is 5. So then if I find f of 5, so we'll go over here, 5 squared would be 25. So 25 times 2 is 50. 50 plus 3 would be 53. So there's more than one